Get going.
Morning, all. Tuesday, 2022. White day today. For lunch in the main line, baked ham, chicken nuggets, turkey cheese, Caesar salad, barbecue grill, cheesy pizza, sausage pizza. The activity scheduled for today. Reminder that at the end of the week, Friday, no school on Friday due to Easter break, and that includes Monday. Next meeting for National Honor Society, April 27th during lunch, and this is the Leichenberg Room. All members are required to attend. Please bring your service hours and forms. In next week's Paper Fine Art Boosters, sponsoring the dessert social for the musical Beauty and the Beast on Thursday, April 21. The social will be from 6 till 7 in the Commons prior to the beginning of the musical at 7. It's also played Friday night. Money raised up for fine art. All please stand for the pledge. To the flag.
This is the part where you stop talking and you actually do the daily quiz. But how many war stars do you have? Scrub. Alright. First up, gonna find the period and phase shift. Period is gonna be pi over b, not 2 pi over b. So pi over 1, but just pi. The markings of this thing, because I start at my phase shift and then we crack that in half over it to find my first two asymptotes, or there's a period between x-intercept, 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 that means all of these boxes, all of these increments are going to be, instead of quarter marks, half marks. And those are going to be pi over 2 increments. The phase shift, negative c over b, is negative pi over 2 over 1 is just negative pi over 2. So you could have just started with 0 in the middle, if there's anyone who did that. But most of us are more comfortable having negative pi over 2 as my phase shift. You sure you want to drink that? And then pi over 2 increments. 0, pi over 2, pi, 3 pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, negative 5 pi over 2, and so on. With a vertical axis, so some of you don't have that, of 0, 1, negative 1, because there's no vertical shift and my amplitude is still 1. Then you make the same graph every time. There's going to be x-intercept, asymptote, asymptote, x-intercept, asymptote, x-intercept, asymptote, x-intercept, asymptote, x-intercept, and so on. And because it's a negative tangent, we will say up, middle, down, up, middle, down, up, middle, down, up, middle, down. Getting a vertical reflection of our normal tangent. So again, you could have taken that entire thing and just started over here instead. You could have put 0 there. as opposed to this. Okay, so you kind of get your choice. I don't care which you did, as long as you have the x-intercepts are on the right ones, the asymptotes are on the right ones. Okay? Well, did you have a actual tangent-looking graph? You did not try to do a sine or a cosine. Good job. Did you reflect it? Did you have the asymptote at 0 or x-intercept at negative pi over 2? Okay, so somewhere between those two, you started in the right spot with the correct feature. Did you get your spacing on the graph correct? Did you label your vertical axis correct? Questions about it? Cool. Okay. Wasn't our assignment was split 2 parts, right? Yeah. Okay. From 4-4?
I think this is the other part of it, the 4-5, but number 4.
That would be from 4-5. Number 4, they say. All right, graph of A. So, okay, you start with period, not 2 pi, pi over b. B is 1/3. So if I take this distance between asymptote to asymptote, this distance is 3 pi. That means each one of those boxes is going to be 3 pi over 2. So I have to label all of these by 3 pi over 2 increments since there's no phase shift. 0, 3 pi over 2, 3 pi, 9 pi over 2, 6 pi, and so on. Negative 3 pi over 2, negative 3 pi, negative 9 pi over 2, negative 12 pi. And instead of trying to stretch my graph, I'll take the amplitude and I'll just put 0, 3, negative 3. So I can just keep making the same graph over and over and over. So, x-intercept, asymptote, x-intercept, asymptote, x-intercept, x-intercept, asymptote. And in between, you have that pattern of, because it's negative, reflected, up, middle, down, up, middle, down, up, middle, down, up, middle, down, up, middle, down. Like so. It ain't pretty, but that's why we use graph paper. Okay. I think the biggest catch in there is understanding that this is kind of like a negative times a 3 times a tangent of a 1/3 times an x. Like breaking the different parts of it up and what their transformations do. Okay? Womp, womp, womp. Utters? No? Nothing? Cool. What's a reciprocal? Flip numerator, denominator, right? What's the reciprocal of 1/5? Reciprocal of 1. You sure it's not -1? Okay. What's the reciprocal of 0? So 0 can be written as 0 over 1. When I flip it, now it's 1 over 0. Undefined. So, even though it's not mathematically possible, what would the reciprocal be of undefined? 0. Undefined could be seen as number over 0. Any number. If I flop that, I now have 0 over any number, which is 0. That idea that a reciprocal can take a 0 and turn it into an undefined, and an undefined and turn it into 0, is how I get all those bottom functions, cosecant, secant, and cotangent. Because what used to be an x-intercept was a 0. So all of my x-intercepts, zeros, when I reciprocal them, now become undefined. They become asymptotes. I was kind of being facetious here. This is cotangent. This is a half-period translation and reflection of tangent, which is cotangent. Y'all got your unit circle? Okay. What is the tangent of 0? Tangent of 0 is just 0. So what would the cotangent of 0 be? Undefined. What's the tangent of pi over 6? Square root of 3 over 3. So what would the cotangent of pi over 6 be? Okay. So square root of 3 over 3 is 0.6-ish. It's like 0.58 something. So when I reciprocal that, I get just square root of 3, which is 1.729. So small numbers become big numbers. Big numbers become small numbers. Zeros become undefineds. Undefineds become zeros. What you do is you take the whole graph and turn it inside out. And that is our cotangent graph. In cotangent, because I'm taking all of those values and flipping them inside out, there used to be asymptotes at pi over 2 and negative pi over 2. The reciprocal of 0 over number, the reciprocal of number over 0 is 0 over number. Reciprocal of asymptote is now x-intercept. Reciprocal of x-intercept is now asymptote. So everything trades spots. Additionally, if you looked at a tangent graph, a normal tangent graph, the reciprocal of -1 is still -1. The reciprocal of 1 is still 1. So if tangent looked like that, do you see why this just flips? Big numbers become small numbers. 1/5 becomes 5. 5 becomes 1/5. 1/9 becomes 9. So that's why it takes the entire graph and reflects it. Because you're taking all of those big numbers and making them small, and small numbers are big, and zeros are undefined, and undefined is zeros. What you need to know in terms of how do I graph that is cotangent starts at asymptote. So whenever I make my phase shift, I'm not starting at an x-intercept and cracking the period in half over it. I'm doing my phase shift, and that's just my first asymptote. I'm still going to make the period as pi over b. It's still going to be cut that in half to find out where all my boxes are. It's just instead of starting at an x-intercept, I start at an asymptote. Instead of going negative infinity to infinity, I'll start as a main version positive to negative infinity. Everything is cross-eyed bass-backwards because it's a reciprocal. Flip it upside down. Okay? So cotangent and tangent, I honestly believe cotangent is the easiest of all 6 trig functions to graph. Find the vertical asymptote, sketch a graph of thing. So everything that used to be an x-intercept is now an asymptote. So don't draw this part. I used to have intercept, asymptote, intercept, asymptote, intercept, asymptote, intercept, asymptote. That's regular tangent. So I flip the whole thing on its head and say now x-intercepts become asymptotes. X-intercepts become asymptotes. Become asymptotes. Become asymptotes. Become asymptotes. And all of those will become x-intercepts. Now we're going to have cotangent. Amplitude is still 1. So I will still put 1, 0, negative 1 here. I will still have a graph that in between x-intercept and asymptote is going to be the 1 value, or my amplitude value. Because it's cotangent, the whole thing will get reflected. So now it's up, middle, down, up, middle, down, up, middle, down, up, middle, down. I'm going to keep making that same graph. The only difference with this one is that because the period is still pi over b, and there was no phase shift, and my first asymptote started at 0, the period is 3 pi. The distance between asymptotes is 3 pi. So if that's 0, that's 3 pi. That's 6 pi. That's negative 3 pi. That's negative 6 pi. So what are each of these boxes going by? Right? 2 boxes is 3 pi, so half of that is 3 pi over 2. 3 pi over 2, 6 pi over 2 reduced. 9 pi over 2, 12 pi over 2 reduced. And they're negative versions. Okay? Personally, I think these are the easiest of the 6 because I start on an asymptote without having to break it in half. So, I don't. The one that's got the grosser fractions in it. How about that? Okay. So, cotangent. Oh, no. This won't do. This will not do. This will not do. Let's start with just A. Yes!
Wouldn't it just be?
Well, it'll go south to north like a tangent because of the reflection, yes. But wherever my phase shift is, I am now starting with an asymptote instead of an x-intercept. If you can do the tangent graph, you can do the cotangent graph. That's why we're starting out heavy. I see a couple of you doing the smart. Let the calculator do the thinking for you. Phase shift plus half mark x. Hmm? What?
How much do you not like that?
No. Because then you're creating a substitution problem within your graph, which is not simplified. Although that is how I wrote out the formulaic version of this for kids who just don't get it, but they're okay plugging numbers in.
I can't add 10 and 15 pi just normally.
Nope. One's in terms of pi, one isn't. It's the same as trying to say 10 plus square root of 15. Mode? Oh. You need to be in that. Why is that? Okay. Go to mode and answers auto. Oh, you typed it in as a division problem instead of a fraction.
I did do fractions though.
What? Same? No,
Why?
don't use pi. Don't use pi.
Oh,
Just use 1/6.
okay.
You just have to remember there's a pi with all of them. Specifically because those calculators won't do it in terms of pi. No, calculator will not work in terms of pi, or at least the TI-84s won't. So you need to just remember the pi's there. Eh, eh. Oh boy, that's nasty. Well, no, just how Frank decided to split things up. All right, I'm going to say the phase shift is always negative c over b, 2/3 over... Was there a pi missing? There's a pi missing. All right. There we go. There we go. Because otherwise, everything you have is in terms of pi and not pi together. And then it's all gross. Okay. All right, just don't worry about it. We'll do a different one. I'll walk through this one. We'll do a different one. Okay? So, C, negative C, 2 pi over 3 over B, 3/5 is negative 10/9 pi. So, negative 10 pi over 9, period. Period is still pi over b. B is currently 3/5, so 5 pi over 3. 5 pi over 3, remember, gets cut in half to make the asymptote x-intercept asymptote. So my half marks are going to be 5 pi over 6. Ew. So negative 10 pi over 19, I will temporarily call negative 20 pi over 19 over 9 is negative 20 pi over 18. And then I'm going to keep adding iterations of 5 pi over 6 or 15 pi over 18, n. That's why in your calculator, if you don't want to do any of that thinking, you say y is, leave the pi's off of there, x. And let the calculator do the work for you. Now those already have common denominators, but you get the idea. So, negative 20 pi over 18 plus 15 pi over 18 is 5 pi over 18 is 20 pi over 18, or 10 pi over 9 is 35 pi over 18, is 50 pi over 18, or 25 pi over 9, is negative 20 minus 35 pi over 18. Negative 50 pi over 18 is negative 25 pi over 9 is negative 65 pi over 18. It's not divisible by 3. Nope. And negative 80 pi over 18 or negative 40 pi over 9. Yay or nay? Okay. Assuming I can do arithmetic early in the morning. My Bologna has a first name. My midline is going to be negative 8.1. Amplitude is still 1, so I'd put negative 7.1 and negative 9.1. The key to it is that cotangent is asymptote, intercept, asymptote, intercept, asymptote, intercept, asymptote, intercept, asymptote. And because all of those get negated, they're going to look like normal tangents. Okay, so let's try that again, but remember actual pi. Well, let's try that again, but remember an actual pi. There. Chop, chop. I think the midline and amplitude's got to be the easiest part of these. My vertical shift. My amplitude. Phase shift. Period. Because nothing's going to end up reducing here. This actually ends up fairly easy. Because you just keep adding pi to it. Just keep adding 7 pi over 7. So negative 2 pi over 7 plus 7 pi over 7. 5 pi over 7. 12 pi over 7. 19 pi over 7. 26 pi over 7. Negative, what, 16 pi over 7. Negative 23 pi over 7. Negative 30 pi over 7. And then go make a cotangent graph. A cotangent graph will be at my phase shift asymptote, intercept, asymptote, intercept, asymptote, intercept, asymptote, intercept, asymptote, intercept. And because it's cotangent, positive cotangent, we'll go from north to south. Middle, or up, middle, down, up, middle, down, up, middle, down, up, middle, down. Connect the dots. There you go. I also notice as we go through the chapter, as we do more of these graphs, more and more kids start writing their whatever their vertical and horizontal axes labels are outside of the graph, because more and more you're like, God, that's just gross. There's too much stuff in there. Can't even tell what I'm writing. Some of you can't tell what you're writing normally. So you try to put all that in there. Boy, was that a chuckle of an omission. So there's cotangent. Take that concept. X-intercepts are zeros. Zeros as a reciprocal are now asymptotes. When I do a reciprocal, everything becomes inside out. Intercepts are asymptotes. Asymptotes are intercepts. Maximums are minimums. Minimums are maximums. Everything flips inside out. Stranger Things style. You're in the upside down. Okay? Which is why these graphs look so funky. That is the cosecant. Cosecant is a reciprocal of sine. And you're like, what? But then I say, I always make a sine graph by starting where? Zero, midline. And from there, up, middle, down, middle, up, middle, down, middle, right? You go to a maximum, and then an intercept, and then a minimum, and then an intercept. A minimum and an intercept, and a maximum and an intercept. So what happens when all of those flip? Now, my x-intercept is an asymptote, because 0 over number becomes number over 0. X-intercept becomes an asymptote. X-intercept becomes an asymptote. X-intercept becomes an asymptote. X-intercept becomes an asymptote. What's the reciprocal of 1/2? 2. So back here, where I did have the sine of pi over 6 was 1/2, now it's at 2. So if the sine of 0.01 was so infinitesimally small it was almost 0, what's the reciprocal of almost 0? What's the reciprocal of 1/10,000th? 10,000 over 1. So instead of having this, I'm going to get 1/10,000th becomes 10,000. Maximums become minimums. Minimums become maximums. And that's your cosecant graph. You're going to find all of those points, all of those yellow dots, the exact same way you were doing in section 4.4. The exact same way. Same thing for cosine. You're going to find the phase shift, you're going to find the period, a quarter of the period, you're going to make all the quarter marks, and then you're going to say cosine starts at a maximum. Middle down, middle up. Middle down, middle up. Same as if you were going to do a cosine, but then instead of connecting the dots for a cosine wave, you're going to explode them outward and say intercepts are now asymptotes. This maximum is now a minimum. This minimum is now a maximum. You explode it outward. Alien style, chest burster. Your ribs go out, right? All of the parts are going to explode outward instead of inward. And you're still going to find the period and the phase shift and the amplitude and the vertical shift. All of those are going to be found the exact same way. Nothing changes. What's the period of a normal sine function? 2 pi over b. Remember I said that. Kids kind of go a little bit cross-eyed as soon as we do sine cosine, then tangent, it's pi over b. Then we go back to cosecant, secant, and they're like, pi over, wait, 2 pi over e. Okay? So, I got to check what we have here. Oh, yeah. Yeah, they don't give us much practice here. So, I'm going to do one of each. We'll start with one of each. After all this, I'll give you one, and I think that should be sufficient because it really is just a sine or cosine graph exploded outwards. So I start with cosecant is the reciprocal of who? Okay. So it's 1 over sine. So I will treat this like a sine function for now. I'm going to say the amplitude is still 1. I'm going to say the vertical shift is 0. I'm going to have a phase shift of negative c over b, which is just 1, so negative pi over 2. And I'm going to find my period is 2 pi over b, which currently is just uno. Okay, sine graphs. Did they have half marks or quarter marks? Quarter marks. So that means all of my quarter marks are going to be at pi over 2 increments. Take 2 pi times 1/4. So, ruh-roh, we saw that before. If my quarter marks and my phase shift line up, I can start at 0 if I want. But let's not. Okay. All right, now I can do it. Instead, I will just put my phase shift in the middle, negative pi over 2. I'll go by pi over 2 increments of pi over 2, 0. Pi over 2, pi, 3 pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, negative 5 pi over 2. The amplitude was 1, the vertical shift was 0, so 0, 1, negative 1. And I go to make my dots just like a regular sine function. Sine starts at a midline. Up, middle, down, middle. Down, middle, up, middle. And then I remember, like Scooby-Doo style, they take the mask off. Wait a minute, it was Old Man Withers. It's not actually sine, it's cosecant. Blow everything outwards. X-intercepts become asymptotes. X-intercepts become asymptotes. X-intercepts become asymptotes. Now be careful. When you make all of these u's, kind of like tangent was kind of like cubics, these will be kind of like parabolas. Okay, they're not actually parabolic in their growth. Please remember as you make all of these, pinkish? Yeah, pinkish. Don't do this. Don't do, no. Because that's still a maximum. A maximum is not a maximum anymore. A maximum is a minimum. Okay? Oh, it's a function. Its inverse would not be a function. So, a maximum becomes a minimum. A minimum becomes a maximum. A maximum becomes a minimum. A minimum becomes a maximum. Okay? So you set it up just like it's a normal sine function, and then, wait a minute, blow it all outwards. Okay? What if, oh no, they made it gross. Why would you do such a thing? Well, isn't the amplitude still 1? My midline is just negative 17.621. My amplitude is 1, so just up 1 from that. Negative 16.621, negative 18.621. Go find the period. Period is 2 pi over b. b is currently 1/4. So 8 pi, which means my quarter marks are 2 pi. My phase shift, negative c, 2 pi over 3, over b, 1/4. Flip the second and multiply. Negative 8 pi over 3. So, phase shift in the middle. I don't feel like thinking. Clear. Negative 8/3 plus quarter mark x, 2x. I just have to understand that there's pi's with all of this when I write it, because my calculator will not write it in terms of pi. If I go to my table now, it just tells me all the stuff. Okay, I don't have to fraction think. Or, if you're good like that, if I'm going to be adding 2 pi onto things, well, that's 8 pi over 3 negative. If I'm going to add 2 pi to it, times 3 times 3, I'm going to add 6 pi over 3 to it. So add 6 pi over 3 is negative 2 pi over 3. Add 6 pi over 3, now I'm at 4 pi over 3. Add 6 pi over 3, I'm at 10 pi over 3. Add 6 pi over 3, I'm at 16 pi over 3. I'm at negative 14 pi over 3, negative 20 pi over 3, negative 26 pi over 3, and negative 32 pi over 3. Because none of them reduced, that actually wasn't bad. Or let the calculator tell you what they are. Okay? So, I don't care. So I set it up just like this was a regular sine or cosine function. I find the period, the phase shift, the vertical shift, the amplitude. I put all that stuff on there, and then I say, what kind of critter is it? Hi?
Is the first one to the right the 2?
Negative 2 pi over 3, yep. Got him. And y'all lucky that Callie's looking out for you too. She came in here yesterday and called it that I didn't actually write those other 2 points up there. So, yeah. All right, secant is reciprocal of what? Cosine. So I start it like a normal cosine. Start at my maximum, middle down, middle up, middle down, middle up. And then, wait a minute, it was the gardener all along. You take all of those x-intercepts and turn them into asymptotes. You take all of these maximums and turn them into minimums. All these minimums and turn them into maximums. Max becomes min, min becomes max, max becomes min. Okay? So it just flips. Everything's inside out. If the who what? Okay, if the amplitude was 1 and then it had a negative for a reflection, then all that means is instead of starting here, I would have started here. So just all of those U's would be flopped. Okay? So, no, that won't do. That won't do. Not much. Just added one thing onto it. No, we haven't. I want to see what you make of it. We have not seen something like that yet. I want to see what you do with it.
Is that considered cheating?
No, that's actually how you do it. No. I'm expecting you to know how to do everything from the previous 3 classes. Do you see why I get so grumbly? Like, you're supposed to have been doing this for 3 years. No, writing compound numbers. Like Algebra 1. How do I take square root of 2 plus 1? I just write square root of 2 plus 1. And I'm done. And you should have used that throughout geometry and Algebra 2. So a lot of kids will come up to PreCalc having not actually worked with the appropriate terminology or skills.
Oh, that's what I'm missing. The X part. Duh.
Believe me, I want all of you to do well. I love it when kids come back from Trig and Calc and they say, oh yeah, it's really easy. It should be. That's in-depth analysis of a thing instead of doing 15 subjects at once. I love it when kids leave pre-calc, go take their ACT, and they come back and they're all telling me that they've got 27 plus on their math section.
The April scores literally just came back yet.
They did?
Yeah.
And?
I'm unable to sign into my account.
That's what I'm So Finn got a 0.
Okay. The last 6 years or so, 6 years, okay, Mr. Spear has said that kids are coming up to Trig and Calc and they know their stuff. Years ago, pre-calc used to have twice as many kids in it. It was kind of a joke class. You just showed up and did the work and everyone got an A. And then they'd go on to Trig and Calc and get blasted. Okay. I want you to do all the tough stuff here when you can ask questions, when you can bounce ideas off your neighbors. I want to do the ugly stuff up here so when you get to the assignment, you're like, hey, this ain't so bad. If you do it.
Put the really difficult stuff on the board, and then we get to the test, and it's like one thing is on there.
Huh?
It's nice. I like teachers that do that. Because sometimes you have teachers that put really easy stuff on the board, and then you get to the test and don't remember how to do it.
Just like that. Like something super complicated on the board. We're like, you didn't even like chase on this.
No, I like to think of it as when you're in class, that's the practice. That's doing ladder drills. That's footwork. That's crushers. That's, weightlifting at 5 a.m. That's doing all the work so that come game day, it's not a big deal. The body just takes over. In this case, the mind takes over. Well, I coached for years until I got sick of parents. Yeah. Yeah, I coached football and track for years and then hung up the cleats for game club instead. I'm a lot happier now. Parents all think that their kid's a rock star. It's everywhere, but yeah, entitlement is a real deal here. All right, let's do this one. Plus 5 pi. Oh, wait, I can't say that anymore. We don't want to make people feel uncomfortable. I can't say words like entitlement or privilege because they don't exist. Okay. My baloney has a first name. I got 0, 1, -1. Midline is still 0. Amplitude is still 1. That hasn't changed. Period. 2 pi over b. B is only 2. Womp. So my quarter marks. Pi over 4. Phase shift. -c over b, -5 pi over 2. So most of us are probably going to start with -5 pi over 2. You know what? Let's put them in the middle. Let's see how ugly it looks if I actually write everything inside. And then I'm going by pi over 4 increments. If I'm going by pi over 4 increments, I will call this by 2 by 2, -10 pi over 4, and I'll keep adding increments of pi over 4 to it. So, -10 pi over 4 plus pi over 4 is -9 pi over 4. Is negative 8 pi over 4, reduce it. Is negative 7 pi over 4. Is negative 6 pi over 4, reduce it. Is negative 11 pi over 4. Is negative 12 pi over 4, reduce it. Is negative 13 pi over 4. Is negative 14 pi over 4, reduce it. What? Don't write and talk at the same time, apparently. All right. I mean, get it while you can get it. You've been on a dry spell for a while, so get it. Once I'm there, cosecant is a reciprocal of who? Sine. Sine normally starts at midline. So we say up, middle, down, middle. Down, middle, up, middle. And then we remember, what if CAT spelled dog? Dude. Everything gets blown inside out. Okay? You ever seen any of the old like Cheech and Chong movies? No? Watch them. They're horrible. Okay? And then I turn all of my maximums are now minimums, and my minimums are maximums, and my maximums are minimums, and my minimums are maximums. Got a bunch of U's. Okay? Womp. Okay, same thing here. What did I do in this one? Like over 4?
Yes.
Minus pi? Okay. Eli. As I came around, Eli says, "Is this cheating?" And I said, "No, that's just the way you do it."
Yeah, we haven't done a compound number since like 3rd grade, so.
Okay, if I said square root of 2 plus square root of 3, those are not like terms, correct? So that's the answer. If I said square root of 2 plus 2, those are not like terms. That's the answer. If I said negative pi, and my amplitude is 1, so I go 1 above and below it, isn't it just negative pi plus 1? Negative pi minus 1? They can't be combined. They're not like terms. But that is the correct way to write it because that is the simplified expression for that value. I throw that at you as a curveball because we're going to see something similar when we do our arc functions tomorrow. Okay. Phase shift. Negative C over B and my period is 2 pi over B. B is just 1, so 2 pi. So my quarter marks are pi over 2 increments. If I owe you a quarter and I give you 50 cents, you are up 1 quarter. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, negative 3 pi over 4, negative 5 pi over 4, negative 7, and negative 9 pi over 4. Secant is a reciprocal of who? Cosine. Cosine normally starts at midline or maximum. Okay. All right, I should have put on here, what if there's a negative in front? The only thing that changes is I'll start down here and then same business as usual, okay? So just saying, if that happens. Okay, and then middle down, middle up, middle down, middle up. Intercepts become asymptotes. Maximums become minimums. Minimums become maximums. Cats and dogs living together, mass hysteria. Okay? 2 people understood that. So, you good? Okay. Ava, your parents raised you right. Ghostbusters. Original Ghostbusters. Okay. I think we have enough, we did enough gross stuff. Like, you get the idea. It's the same thing as sine and cosine, just blow them outwards. Okay. And then I go and show you this. You're like, come on, man, I just finally started understanding stuff. All right. So right now, the number in front of sine of x is 1. 1 is a constant. How would I graph the function y equals 1? It's just a horizontal line at 1. Plus or minus. Which is why we end up with those boundaries of plus or minus 1. Or remember when we have our amplitude change? What if there's a 2 in front of this? Y equals 2 is the line plus or minus 2. Whatever is in front of the trig function is your asymptotic boundary on either side of it. So what happens when I throw a variable in there? If I said graph the line y equals 2x, do you see how it's just the sine graph? But now, instead of the boundary being at 1 and -1, because there was a 1 in front of it, the boundary is going to be 2x and -2x, because those are the boundaries in front of it. Where it gets real funky. What do you think it's going to look like? I'm going to have plus or minus x squared what? Yeah. Who says it's a...
It's like perfectly upside down.
Perfectly upside down.
Like click on it and flip it around.
Yeah.
It'll be a perfect.
I mean, I'm usually writing upside down when I'm sitting across from a kid anyway, so I read and write upside down. So, okay. Unintentional consequence of tutoring kids for 25 years. Do you see how whatever's in front of it just creates the north and south boundaries of it? Okay? We ain't doing that. I just wanted to show you it because it's cool and you'll do it later in math. Okay? But it's, you do the period and the phase shift and the vertical shift and the amplitude. You do all of that stuff the same way. It's just now the amplitude becomes a asymptote above and below it, which it always was, but now it's going to have a function to it. Okay? Now, I would love to go through that stuff, but turns out you don't even do it in trig. Like, that's college trig. So, if you would please, shoop, shoop, gone. Okay. And then I wanted to include in here, again, when you do an ACT, okay, we're just talking about this. When you do an ACT, out of those 60 math questions, 50 of them are going to be through the first like 2 chapters of PreCalc, which is essentially through college algebra, through algebra 2.2. Okay? But everything after that, those other 10 questions are just a grab bag of who knows what from PreCalc, Trig, Calc 1, Calc 2, and stats. It's just a grab bag. You don't know what you're getting. It is different from test to test. They might have stuff about summation in there. They might have stuff about damped harmonic motion. And if you've never even heard of it, I don't know. You just have to guess. Which, when you come do the ACT review with us, that's what we tell you. If you're staring at a problem for 10 seconds and you don't have a plan yet, just mark something, circle the number, move on. Because the time matters. You have to average 1 minute per problem. Okay? So, damped harmonic motion is something that you get more into when you're talking about particle physics, college trig, you start getting into Calc 2 plus. The idea is, this is how you start. Have you ever heard of like resonance? Like harmonic resonance or harmonic reinforcement? Have you ever done the wet glass trick where it makes all the noises, right? Can anyone do the? Yes.
Well, like,
Yeah.
I've seen videos of it. I haven't seen it.
So it has to depend on the friction coefficient around the edge of it. It has to depend on the shape of it so that the sound waves hit each other in a way that they can harmonically reinforce. So instead of dampening down, it actually makes the wave bigger. Anyone have noise canceling headphones? Okay, that's how noise canceling feature works. It takes a microphone and whatever sounds are coming in, and it puts a anti-wave to it, the opposite wave, to cancel it out. This is just an application of periodic functions, where I can use that to, anyone seen like soundproof paneling on walls? It's like a big foam cutout that's kind of wavy. Okay, they use that because when the sound wave hits it, it doesn't reflect off of it nicely. That's why even if I take you out of here, just take human bodies out of here, and I do, I don't know, a lesson video during my prep hour third, it's going to echo a lot more because there's less mass in the way. There's nothing to dampen or to break up the sound waves. Have you ever moved all the stuff out of a room? Your bedroom with all your crap in there versus your bedroom with nothing in there? Loud, echoey, right? This is just an application. But I double checked with Mr. Spear, and he said you do not do this in his trig class, so it is not necessary for us to do it now. Cross it out. Okay. Now normally, I would continue into 4-6 right now. But second hour typically runs about 7 to 10 minutes behind you. They do better though. Okay. They take a little bit longer, but their performance is a little more consistent. So I'm just going to cut it off there because that'll put about the right amount of time for second hour. Everyone's doing a video tomorrow. I'm not here. I told you that. Okay. I'm out. Mama Bear needs to go to appointment specialist in Rapid, so I'm at home on daddy duty. I'm still available if you text questions on Remind, but bring your headphones. It's our normal in-house sub. I forget her name. They hired her this year to just be a sub every day. Not Benton. Younger gal. I don't know. I hope not. So,